We're recording these two. So if here we have describe how the graph of the second function compares to the graph of the first function and determine in mapping notation. So your graph has to have a specific curve. It has to be an increasing graph or a decreasing graph. And that part doesn't show up in your transformations. So up here it shows, so we have y equals c to the x. So y equals c to the x is the original. The c stays the same. And then the c stays the same. And then this is our translation. So a, b, h, k. So the c part, that base of your exponential function, appears nowhere in your transformations. But in order to compare two graphs, the bases have to be the same. So is this graph, this current original 4 to the x graph, is that an increasing exponential or a decreasing?
Decreasing.
We're multiplying by what each time? 4. So is it going to get bigger or smaller? Bigger. If I start with 1, I'm at 4. At 4, I'm at 16. 16, I'm at 64. And I grow really fast, right? So it's an exponential growth with a base of 4. Remember, if b is greater than 1, it's growing. If b is between 0 and 1, it's decreasing, right? If it was a quarter, it's going to decrease. So the 4s do not matter other than the fact that they have to be the same. I have to be comparing two graphs that are increasing by 4. Okay, so I'm comparing those, but that number 4 appears nowhere in my transformation. What would this 2 do? Vertical stretch by a factor of 2. About the x-axis. And then what does this 2 do? It's with the x. So it's a horizontal translation. Phase shift is only in trig. So we're back to horizontal translation. Two units what? Right. So we have to do our mapping. Our mapping and words are the same. So xy becomes, I have to go 2 right, so I'm going to go x plus 2. And then our y's never changed, so it's a multiplication of 2y. You try that one. So I need to have the same base. This is base 2. This is base 2. Right? Subtract my 4 over. So I would get y equals negative 2. Instead of writing x over 5, how could I write that? 1/5 x. So I have a horizontal stretch. Horizontal stretch by a factor of 5. About the opposite axis always, so about the y-axis. My negative is in front, so it affects the y's, so it is a reflection of the x-axis. Always about the opposite axis. And then I have a vertical translation. Forward and down. So we discussed yesterday that the horizontal asymptote on an exponential function is on the x-axis, right? That horizontal asymptote sits on y equals 0, the x-axis. We also discussed yesterday what's the only thing that can move that? What's the only thing that can move that y equals 0? Yeah? Oh, I skipped it.
Horizontal transformation.
Vertical translation, yeah, we'll do it. I get 5x, comma negative y minus 1. Vertical translation can move your asymptote, yeah. So if you have a horizontal asymptote, the only thing that can move it is the vertical translation. And then we talked about that your vertical asymptote or your horizontal asymptote is just equal to whatever the heck the vertical translation is. No. So it's just your vertical translation, what it is. So what's the vertical translation on this one? F of x? 0. What's the vertical translation on this one?
No.
0. What about this one?
No.
0. What about this one?
No.
0. So in technicality, all of these have horizontal asymptotes. At y equals 0. So on that x-axis, they have an asymptote. An asymptote where the graph can't be. It's that dashed line where the graph can't be. Correct? So if for every single one of these, I have y equals 0, a dashed asymptote where the graph cannot be on the x-axis, what are my x-intercepts for all these graphs?
There is none.
There is none. I have a dashed line that cannot exist on 0, right? So all of these, because they have a horizontal asymptote at y equals 0, they have no x-intercept. When I hear y-intercept, what should I think? X equals 0. So for those, we'd actually have to find them out, right? So we're going to go f of 0 for all of them. F of 0 equals 2 to the 0. What is 2 to the 0? 1. So this is function notation for the y-intercept, correct? But we don't ever leave our y-intercepts as that. We say y-intercept, and then we always state it as a what? Coordinate. So 0, 1. So if we want the y-intercept of b, we do f of 0 again. And we get 2, and then 10 to the 0. 10 to the 0 is just 1. 2 times 1, which is 2, which is function notation. But I want it as a coordinate. So my y-intercept is 0, 2. You do C and D. Okay, so for this one we get f of 0 equals 2, and then 10 times 0, which is 2 to the 0, which is 1. So my y-intercept is at 0, 1. In this one, I have f of 0 equals negative a half. 3 over 5 to the 0. Anything to the power of 0 is 1.
Negative 1.
We do negative a half times 1 is negative a half. So you get 0 and negative a half. That's all I need. I want you guys to discuss with people beside you. Explain using transformations why the graph of y equals 1/3 x is a reflection in the y-axis of the graph of y equals 3 to the x. My hint to you is we can only compare graphs that have the same what? Base. So perhaps change that one to the same base. Which equation is the original? 1/3 x or 3x? 3x. Or 1/3 3x.
3 to the x.
3 to the x is the original. And it's converted to y equals 1/3 x, which I need to be converted to y equals 3. Correct? I need it to be 3 because I can't compare these unless it's actually a 3. They have to be the same base. Correct? This is 3 to the 1. If I could get it to come up here, it would be 3, wouldn't it?
Yeah.
How do I get that to go up there?
Negative 3.
You change the exponent to a negative. If it's a negative, you can move it to the numerator, become positive. If it's a positive and you move it to the numerator, it becomes negative. The sign just changes, right, on the exponent. So this is actually going to be this 3 to the 1. If I move it up there, it becomes 3 to the negative 1. And I still have this x sitting out here. And then this becomes 3 to the negative x. When I have a negative x, what do I have? A reflection in the y-axis. So that's why you have a reflection in the y. Now remember, if I had a graph, recording, I can't write on the whiteboard. If I had a graph of 3 to the x, and am I sketching this for a test mark? No. If I was sketching this for a test mark, would I have to draw all the appropriate coordinates so that Mrs. Lepp would give me full marks? Unfortunately, yes. Okay, so if I have 3 to the x, it would be growing exponentially by 3. Multiply by 3, multiply by 3, multiply by 3 every single time you move from one to the next, correct? If I had a third, it would look the exact same, but it would be going this way because I would be not multiplying by 3, I would be dividing by 3, correct? Each time. Divide by 3, divide by 3, divide by 3. So if this was 27 here, this would be 27 here because I would divide by 3 and I would get myself down to a 1 down here eventually, and they both be 1 at that point, and then it would become a third, da, da, da. This would decrease, this would increase. They reflect perfectly on the y-axis because they are literally just, one's multiplying all my numbers by 3, and the other one's dividing all my numbers by 3. So as fast as this one over here is increasing, is as fast as this one over here is decreasing. Therefore reflecting on that y-axis. But why? Because I changed that base from a third to 3 to the negative 1, and therefore you see that negative beside the x, which is a reflection in the y. Okay? Describe how the graph of the second function compares to the graph of the first function. What am I asking you to do when I say describe? State transformation. Now some people are like, do I need mapping? Did it say that? No. So I just need transformation. So these have 10 and 10. They're the same. That is good. That means they will not be discussed anywhere throughout our transformation. They are a base 10 function. So is this an increasing exponential or decreasing? It's increasing because it's going up by 10. 10, 10, 10. It's going to grow really fast, right? Start off 1, I have 10. 10, I have 100. 100, I have 1,000. 1,000, I have 10,000. Like, it grows really fast when it's base 10. So I have on here no stretches. I have a reflection. It's with the x, so I have a reflection in the y-axis. And I have a vertical translation. Yeah, because I specifically said, what does describe mean? And everyone said, it means to state transformations. And then I said, does it say anywhere on here mapping? And everyone said no. And then you said, is it a problem that I did mapping and not transformation? Yeah. Okay, vertical translation, 3 units down. What's the problem with B? This needs to be to a 2, so then that will make this negative, correct? So we get a vertical stretched by a factor of 5 about the x-axis. We get a reflection. Oh, we get a horizontal stretch by a factor of a third. About the y-axis. And a reflection in the y-axis. C, that 1/6 needs to switch to a 6, which raises this to a negative 1. What's a negative times a negative? Positive. So there's actually not a reflection. There's a vertical stretch. By a factor of 2 about the x-axis. And a vertical translation 3 units up. guys, what would my asymptote be for A? It would be a horizontal asymptote. At y equals -3. What would this one be at? 0. Y equals 0. What would this one be at? Y equals 3. Because it's only the vertical translation that actually moves that asymptote, correct? And this one will be at 0. This one just has a horizontal stress by a factor of 2 above the y. You're going to flip over and do the next two examples. The top example on the next page is a multiple choice.
Yes.
So it's not like a A, B, C, D parts. So you're doing the examples on the next page. Example 5 and example 6, try them out. This one here, example 5, what is the asymptote? What's the equation of the asymptote? C. It's y equals 1 because it's our vertical translation. Now, example 6, we don't even have to type it into our calculator. We know that this is a what function? Increasing or decreasing? Increasing by 5. 5s, 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 right? So if I have an increasing function by 5, it would look something like that. Let's pretend. Oh, here would be your asymptote. Your asymptote would be on the x-axis. What are we doing? Our asymptote's actually moving to a 3, isn't it?
Yeah.
So now we're at y equals 3, and we're moving this graph 4 to the left, are we not? So instead of it being there, it would be something like this. Now, if you sketch a graph like this on your test, Mrs. Lepp is going to be thoroughly unimpressed with you.
I know.
But we're sketching this so that we can actually look at it and use it, right? If I actually ask you to sketch one on a Cartesian plane, I want a whole bunch of coordinates and I want an accurate looking graph. Yes? Now, why did I sketch this one so quickly? Because I can see that there's no graph down here, is there? So, I want the domain. The domain isn't going to change. It's x is an element of the reals for all exponentials unless it's a word problem. That's set notation. Or an interval notation, negative infinity to positive infinity. Now for my range, I didn't need my calculator. Did the graph reflect and drop below? No, it's still above. And it's above what? 3. So we're going to say y such that y is greater than 3. Y is an element of the reals. Or 3 to infinity in interval notation. Because I did a really crappy sketch off to the side, we also see what about x-intercepts? There are no x-intercepts. And for the y-intercepts, I plug in x equals 0. So I'm going to get f of 0 equals 5 to the 0 plus 4 plus 3. So that's 5 to the 4 plus 3, which is 625 plus 3, which is 628. So I say my y-intercept is not 628, or y equals 628. It is 0 and 628. You put y equals 628, that's actually a horizontal line at 628. Is that a y-intercept or a horizontal line at 628? Horizontal line. So that's what it's right here. And the equation of the asymptotes, you can't just write the equation. You have to say it is a horizontal asymptote because log graphs are inverses and they will have vertical asymptotes. Horizontal asymptote at what? At y equals 3. Your homework is page 355, numbers 4 and 7. Number 4 is matching. 7 is a little bit more work, but still not crazy. It's 2 questions.